So very good morning, all of you. First of all, I welcome everyone for this webinar jointly organized by Francis Xavier College of Engineering, Tirunelveli and Scientific Computing Solutions, SES India. See, the main objective of organizing this webinar is to focus on to the student community particularly. Of course, there are 1,000+ registrations or majority of the student community, particularly engineering students of different branches, interestingly. And of course, we have hundreds of faculty members also enrolled for this webinar. So most of you have some idea about the analytics and data science field and its scope in the coming years. So as we are in the lockdown period, so the how this economy is going to bounce back post lockdown, and you're skeptical, and you have a lot of thoughts in your mind, how my the situation of the job market will be. Definitely it is not as equal to the situations how we were at maybe probably uh, October, November, December of 2019 and early January. We had a very good time, a very good momentum, and the lot of recruitment was going on at a different segment, right from the freshers to 5 to 10 years experienced data scientist. But of course, uh, post lockdown, definitely, uh, not only in India, across the globe, we can sense some kind of slowdown in the recruitment process across different verticals. Definitely, mildly, it will affect our analytics domain too. But this is the best time you can equip yourself, your analytics skills, and the related softwares and the mathematics. Very importantly, you should understand the data science field is about yeah, you need to. There are three things. One is what the tool and the software. What we are going to discuss today is Python, and number two, it's a you should have a very good passion towards math and statistics. Uh, what you have studied from your school days, statistics, of course, really it makes sense in today's analytics trend. If you have a lot of interest playing with the data, definitely this is the field for you. And many of you coming from the different background like mechanical engineering, civil engineering background, computer science and IT, circuit branches like ECE, Triple E, instrumentations, biomedical engineering, and so on. Irrespective of your discipline, this data science field is common to everybody because in every field we work with data, right? Like civil engineers, they're working with, for example, they wanted to analyze the concrete strength. What are the different propositions of the materials they have to mix up to get the expected strength of concrete? And similarly, the mechanical engineer students, you work with several data related to manufacturing, production related data. In fact, today's session, I'm just going to highlight an interesting data set. It's a very popular data set like CARS, CARS 93 data set. It's very popular data set among the data science community, analytics community. Because as a car data set is quite everybody will understand easily. Okay, we know that some technical specifications of car in terms of what is the engine capacity, the horsepower, how much of mileage that car gives, model, and some basic attributes about the car. Uh, so I'm going to briefly going to tell about how fascinating this data science field is, how really you can take it as your career option. And in fact, the last 2019 survey tells it is the highest paying job. The data scientist domain is the highest uh, paying job market in recent times. But you should be equipped yourself with the necessary skill sets. So that is what we are going to discuss in this webinar. So the people from the circuit branches like ECE, EEE, and instrumentations and all, today we are living in IoT, Internet of Connected Things. So there are lots of sensors across us, and how data has been collected from the various sources, like different atmospheric sensors, and what kind of decision making we can do with those sensors, uh, data-driven decision makings. So definitely, the fields like speech recognition, speech classification, the face recognitions, like image processing, pattern recognition application, computer vision applications, the driverless car applications. All these applications, definitely those people are coming from the circuit branches. You can appreciate because you have a very good sound knowledge on signal processing, image processing, and of course, you had a very good knowledge on statistics and probability theory and random process. In fact, lot of concepts in the data science is borrowed from information theory. As you get along with the subjects, gradually you can understand. So definitely, the people are from the electronics and communication background and electrical engineering, or if you may be from instrumentation background, definitely you people also can appreciate this field very well. And obviously, there is no doubt computer science and IT engineering students, you will love it. And already you have studied a different kind of databases and all stuffs. And mildly, you might be having a little doubtful about what is the difference between data science field as well as big data. So there is a definitely there is a difference in the work profile. So you should not mix up with various terminologies and jargons in the job market. You should have a very good clarity on what really you are interested in, what is your strength, where exactly you can fit in. Okay. So once I tell the workflow, you'll get some idea whether you are going to really fit in the data science role, or you're going to fit into the big data role. Basically, we have two major domains. As you see, every industries, they have their own business data. What they wanted to do in the current situation is they want to convert their data, the current data which is available in their own organization, into valuable business insights. In turn, that is going to help them to make a data driven decision making. Okay, that is the whole agenda and idea behind why every industry is now moving towards artificial intelligence, analytics, and so on. So again, when we are talking about this, you might get confused with the terminologies like what is AI, okay, what is machine learning, and what is deep learning. All are interrelated terminologies, right? So you should have some good clarity of understanding. So I would say artificial intelligence is a huge, the superset of all. Okay, I would say this is a superset of all artificial intelligence, right? You wanted to predict the a person is a healthy or a disease. You need a model. That model is going to predict whether the person is having uh, a particular disease or not. Definitely, it is a having an artificial intelligence capability that model is having, and anything, any mathematical model or any your software program which has the capability to work like a human expert. As a medical expert, as a healthcare professional, how a doctor diagnose a disease, suppose your model, artificial intelligence model, is going to do that job, definitely we can call it as artificial intelligence. Okay, that a model, a piece of model, or a piece of computer program which is going to make a human like decision making, that is a classic definition of artificial intelligence. And what about machine learning? Machine learning or the set of algorithms, okay, to achieve that artificial intelligence application process. So we have plenty of machine learning algorithms today. We have a bucket of several algorithms. So the purpose of all these machine learning algorithms going to learn from the business data. So instead of writing the if-then rule explicit rules, these algorithms trying to find out certain patterns in terms of their model parameters. It captures those informations. In turn, those algorithm is used as an application for artificial intelligence. So we have plenty of algorithms ranging from simple linear regression model to neural network model. So you'll be wondering once again, where deep learning exactly fit in here in this space. Of course, deep learning is also one of the machine learning model, but this artificial neural network exists three, four, many decades before, right? But today we are talking too much about the neural network because those days we don't have that powerful computational platform like today we are enjoying with a platform called TensorFlow and Keras you might have came across. These are the powerful computation platform today. It is possible. That is why these classical neural network is getting a new shape in the form of a deep learning. Of course, little changeover in terms of architecture and all. So deep learning is also one among the machine learning model, which is a why. What is the purpose of machine learning model is to solve this. You need to build an algorithm. That algorithm should learn from the data, the key patterns, and in for future in real time scenario for their business use case, they need to use such models to predict. So irrespective of the application area, like healthcare application I was mentioning, you can use it for the financial domain, banking, finance. So you can predict a particular customer of a bank will default a loan or not. You can use such machine learning algorithm. We can use it for the stock market trading, whether a particular stock value will go up today or tomorrow. Um, so the applications are ranging countless, right from finance, banking till e-commerce, retail. So you know that we are very the e-commerce portals like Amazon, Flipkart, and all. They are giving some insights about a particular product when you're surf through particular product descriptions, and they give some kind of inputs to you to the customers saying some recommendations to you, right? The customers who purchase the so and so product also purchase this product. This is just one kind of an algorithm which I was mentioning about the machine learning algorithm. So those kind of recommendation systems we call it comes under the recommendation engines, we call it as. That is the one part of your ML algorithm, one particular application area. Like we have several kind of application areas in machine learning algorithms for the different real-time problems. So data science is the fundamental science to do everything. So data science, it is a science which is going to deal about the data because after all we are going to work with the data. So what are the different ways you can treat the data right from the data acquisition part? So how we are going to acquire the data, then what are the different measurement scales in the data, and how we are going to deal with uncertainty in the data in terms of so incorrectness in the data, missing values in the data. So we call it as a data cleaning process and stuff like that. So once you prepare the data, how you are going to take that data to the model building, and how do you do the performance evaluation and validation and stuff. So let me summarize this data science analytics or the complete this AI artificial intelligence workflow in your real time scenario. So always we should start with the business problem. What is the business problem, right? So in every business, people wanted to have their artificial intelligence capability. So the ultimate goal is data. Everybody they wanted to make a data-driven decision making. One simple example I would say, like for a data-driven decision making. Imagine one fine morning you just get up from the bed and you just feeling a little feverish, and your mom is touching your cheek and she's telling, yeah, there is a mild fever. Okay, this is very qualitative, right? Why I'm saying a qualitative, you have not done any measurement about the temperature, how much temperature you have. But imagine rather touching if I measure the exact temperature by the thermometer, okay, so thermometer reads uh, uh, your temperature in terms of Fahrenheit, and it's going to say, so you have so and so temperature, which is of more quantitative, right? So your real life problem also, your real life data also will be having a mix of quantitative and qualitative data. And the whole idea of your data science application area, that is artificial intelligence and analytics, the whole idea agenda is we wanted to make a data driven decision making in our business problem. It means what? To 10 years before, even to couple of decades before, and those days still people, many people are successfully making the businesses, right? They were doing businesses successfully without data science. Now only we are talking too much on this data science, artificial intelligence, analytics, and so on. 20, 30 years before, nobody was using this, of course. Uh, like the level of quantum level what we use today when compared to today's. So those days, people were doing business, they were making a business decision based on their experiential knowledge, right? So experience. So purely they trust their experience, intuition, and gut feeling. So everybody, each and every individuals, we have an experience, intuition. Once you are master a particular craft, right? Suppose you are a genius in playing guitar, or you are expert in playing piano, or whatever the skill you are master. Once you get a very good experience, so always your experience will drive you in certain playing certain notes, or your intuition will guide you. So similarly in the business also, uh, already the domain experts, they have a rich amount of experience in their business, day to day running the business. But that allowed, in today we are living in the information age, right? So that is why every industry, they started thinking about, we are generating lots of data in today information age. Is it any meaningful insights I can draw from this data? In turn, those meaningful insights should lead to a very meaningful data driven decision making. Thereby, yeah, every company look for increasing how I can efficiently uh, operate my strategies, and thereby every company, they would like to get a profit making. That is the whole idea of introducing artificial intelligence in their everyday business problem. So understanding the business problem and the client requirement is very crucial part of building any AI related model. So right from the business problem, so what is actually required? Based on that, you have to look for the different data sources. Okay. So what are the different data sources? In every organization's data will not sit in one particular source, right? So you will have your data will be at different places. Suppose a particular company is dealing with IoT related data, sensors data. So you have to acquire all the data from the IoT devices. Or if some organizations, it is like all the production level data are stored in SQL tables and all. Or some people will have everyday data generated in the spreadsheet, simple spreadsheet, and Excel spreadsheets and all. So how basically your data are sitting at the different sources, and maybe you people are taking data resources from data lakes or data warehouses. Okay, so data warehouses. So initially I was talking about you should have a differentiation between data scientist and big data architect. There are two roles are there. If you wanted to focus more on the data, if you are very good in already dealing with database and databases like Oracle database, IBM mainframe, and several years already worked with, you are very good in the SQL data handling. So if you have too much passion towards data handling, data acquisition, and data merging process, if you are fascinated about that. So today in the big data world, we are dealing the big data uh, in terms of different, uh, the latest terminologies. dealing with the big data organization. They have a big data in certain organizations. They have it in Hadoop clusters. We call it as a HDFS file system, or Spark. Their data is spread in their RAM spaces. We call it as a Spark. So if you have passion in dealing only with database management and organizing, collecting the data, organizing and collecting the data, merging the data. So we call it as a big data architect. This profile is called as a big data architect. Here you are not going to do anything working on knowledge discovery part, or you are not going to do work with any machine learning algorithms and all. Your role is to streamline all the data which is coming from the various sources. So collect, accumulate, and give the data in a proper format to the data scientist team. So the mostly the big data engineers or big data architect role is in data uh, collection process from the various sources, and you're giving in a proper format to the data scientist team. And of course, again, this others data engineer role will be very crucial when once the model building is done by the data scientist team. Again, the data architect will come in place to deploy the model to the client. How the client is maintaining their data resources, whether the client they have a HDFS file system like Hadoop or Spark file system, or they have simply they have the data in their SQL base, or they are maintaining in the cloud platform. How the client data, their day-to-day production data is streaming in. Accordingly, the architect role is to deploy the final machine learning model to the client requirement. So again, the data engineer is playing a crucial role. So once the data is presented to the data scientist team, from here onwards, the data science part will taking into picture. So data scientist. So what are the goals and objective of a particular data scientist once the data is pulled and it's presented to the data scientist team? So the data scientist team, they started analyzing the business problem. So what need to be done with the data? What we need to do with this data to solve this business problem? So right from they start exploring the data. Once they explore the data. So in data science, we call this as a EDA, exploratory data analysis. So we can also say visual analytics with just presenting a dashboard. So these are all the different terminologies related to when you start exploring the data. And once you start exploring the data, there are various understanding you'll come to know about the data. What are the different kinds of attributes and variables in your data? What are the characteristics? So I'm going to come to that part very shortly. So exploration level, if you do in terms of represent the whole data in terms of graphs and charts and draw some story out of that dashboard, that is the exploration. Of course, whatever the real data, it is not perfect. So it has lot of uncertainties, as I mentioned already. So once you do the exploration only, you'll get to know about what are the flaws in the data in a particular attribute. So that you can identify while you are visualizing the charts, and whether the data is perfectly distributed, continuous normal distributions. These are all the terminologies you may not be aware of. So you just try to understand this in a broader picture. So once you explore the data, you'll get to know about what are the different kind of data cleaning or data transformation techniques I need to do to prepare my data set very suitable for the model building. Okay, data cleaning or data transformation, different data transformation techniques. So once your data is ready for modeling, next you need to work with what type of model is more suitable for this data. So broadly speaking, when we start building a machine learning model with the goal of building a prediction model, in general, in broadly, we have a regression and classification model. Of course, we have some special cases, as I mentioned, like recommendation system is a special case. And we have when we have a time series data, there is another set of data which is of a very special case, like a time series data, uh, hourly recording of stock prices, trading prices, or even daily recording of gold prices, or you can say the fuel prices. So always you have a timestamp attached with any data set. Those data sets will come in an exclusive category called time series data analysis. So those are the subfield of ML. So we have to master it. There are certain data we are living with lots of text, right? We are living in you're giving a Twitter feed or comments uh, about a particular product or services. Those data are all text data, right? So to deal with those text data, again we have a specialized field called natural language processing, text analytics, text mining. But predominantly, what I'm focusing in this session is I would like to focus on tabular dataset, numerical dataset. What are the predominant model possible with working with a tabular dataset? So I'm not particularly focusing on a text related data that comes in text mining, or it's popularly called as NLP. So the other subfields I just mentioned in the bracket, because you should not come to the conclusion only all the ML models, it's dealing with regression and classification only. So we have other models like natural language processing. It's also called as a text mining. We have a different set of algorithms to deal with this. So of course, we can do a prediction model for text data also, but so handling a text requires a special treatment. No? So how we are going to convert the text data into a numerical representation and all. So for that, we need to have a special understanding on deal with text related data. And again, there is a specialized area when you deal with time series data. As I was mentioning, even atmospheric data set, like to forecast the weather. Suppose I have a last 5 years uh, the monsoon data set. Once the monsoon is onset, so daily I have a report of each and every day. For example, starting from June 1, how much of rainfall recorded in a particular area in which the monsoon has started. So June 2, how much of rainfall recorded? June 3. This is a date associated, right? So such kind of data, we do time series analysis. Time series analysis. So predominantly we use the word forecasting for time series dataset, forecasting. So we should not get confused between the terminologies here. So prediction is different from forecasting. So prediction, generally we refer regression and classification model as the prediction models. And the forecasting, we use it generally for the time series data, we use the word forecasting. And of course, recommendation engines. Again, the recommendation engines comes under the special categories. We have a different set of algorithm to deal with the recommendation systems. Okay, and so this session, I just wanted to highlight on a tabular data set. What are the different prediction models we can work with? What is the scope? So I just quickly tell the difference between regression and classification. This is simple. For example, your data set is about some meteorological data set. You wanted to predict a model. A model has to predict and say uh, for a particular set combinations of atmospheric parameters, like if I take a parameters like today's temperature is this much and the humidity is this much, wind velocity is this much, so on, so and so these atmospheric parameters. So what is the probability it will rain today? Okay, so probability in the sense, again I just wanted to calculate what is the probability, what is the chance of getting a rain, or it is a no rain day. So I wanted to just simply predict with this whether it's going to rain or not. So that kind of model, because my prediction variable, my outcome variable, it is going to be a qualitative in nature, right? Whether it is rain or not. Okay, rain or no rain, no rain day. So if your outcome variable, the variable in which you are going to predict is very qualitative, like very disease or healthy. In a healthcare data set, I would like to say whether the particular person is having a disease or healthy. Not necessarily two classes, it can have a multiple classes also. So healthy person, T1 type of cancer, T2 type of cancer. So now it comes multiple classes, right? So, but the outcome variable is a qualitative, it's a categorical. So such models, I would say like a classification model. Okay, instead of predicting whether it will say rain or no rain day, assume that my model, I would like to build a model. This time my model has to predict exact millimeter of rainfall. Okay, it's going to have 58 millimeter of rainfall for so and so combination of independent variable. Generally, we use the term independent variable because we are going to predict the amount of millimeter of rainfall based on these independent variables. So I'm going to call this as a dependent variable. This dependent variable, why we say it's a dependent variable? Because they depend on these independent variables. If my dependent variable is of quantitative continuous in nature, then I build a prediction model. That name we called as a regression model. That is a fundamental difference. But ultimately, we call both these model as a prediction model. Are you clear? So the data scientist role is to build a suitable prediction model which solves the business problem. What is the business requirement? What prediction model will really, whether it's a regression model is suitable for this business problem or a classification model is suitable for this business problem. Of course, we have a special cases like these things. Okay. So that will come whether I need to work with time series data because your business problem deals with the forecasting, you need to work with time series data. If the business problem deals with the recommendation system to the customer, you need to work with recommendation engines models. And of course, your business problem is dealing with text related data. We need to work with text mining applications. So once you do the model, okay, you have to choose the appropriate model selection. And once you build the model, okay, next you do the build the model. Of course, building the model requires a lot of steps, internal steps involving like choosing the right set of features, right? Choosing the right setup. I should not use a feature which is not relevant to predict the rainfall. So we have to be very careful in what are the right set of features, what are the different strategy to choose those features, what is the statistics governing in the background in choosing these features and all. So your data science is going to deal with that. So we have to build a model based on those understanding. I build a model. So how do we make sure that our model works perfect, right? So we need to validate the model. We need to do the performance analysis, validate the model. So we have a very standard validation technique like simple train test split as a point validation and k-fold cross validation techniques are there. So what kind of validation method I'm going to use for my model? So if it is a regression model, I have to use the performance metric related to the regression. So the validating the model should be related with what performance metric I choose. If it is a regression model, we have a set of performance metric. If it is a classification model, again, we have a bunch of performance metrics. So according to the model, we need to choose the performance metric and we need to validate the performance of the model. So typically we will be performing k-fold cross validation. So these are the terminologies. Those people are new to this field is it is too early to understand these things because as I told you, try to get the overall picture of this field. Then you can gradually you can explore each and every step how actually it takes place, right from taking the data, exploring the data cleaning, model building, and validation, and finally deployment. So once your model is validated and finally your data is ready for the deployment, right? So of course, when you do the validations, we need to do little bit of fine tuning required. Okay, so fine tuning is required. So again, here you'll be learning about on what basis I will be fine tuning the model. So there are the error is broadly categorized as bias error and variance error. So any machine learning model is associated with these terminologies, bias error and variance error. So when you do the performance evaluation, you'll come to know that how much of whether your model is too much suffering with bias error or too much suffering with variance error. Accordingly, you need to fine tune your model, and you need to optimize your model, optimize the model performance. So all these things, it involves a lot of mathematical understanding and statistical understanding it requires. So the data scientist role is to do all these steps and optimize the model. Finally, your model is ready for the deployment. Your model is ready for deployment. So from here onwards, again, your architect team will take care of. So what according to the client requirement, right? Your client day-to-day file is your data is streaming in the form of a simple JSON file, or whether it is like a SQL or Hadoop cluster. Accordingly, your final model will be deployed and streamlined with the production scenario. So this is the complete workflow of typical workflow of building a machine learning model, and the science governing this all these steps is the data science. Now let us focus on certain basics. Okay, certain basics, so that you'll get to know about what really you need to uh, start the moment you have a data uh, in your hand. What are the things, quick things you can do with play with the data? So this will give you at least some understanding and interest in this field. So let me start with, when once you start analyzing the data, so you know the data science is a field which is going to deal with the data right from the data acquisition, data processing, data understanding, data cleaning, and um, getting some pattern out of these data. So it is about science about data. So when we talk about the data, we should know about what are the different type of measurement scale. Every real-time data is a combination of a mix of various kinds of data. So the very fundamental idea about a data science, we should start with, how do I measure a particular variable? So I would start with the different measurement scale. So what are the different measurement scale? So there are four major measurement scale when we start measuring data. I will just start with the simplest, and we'll go with the uh, simplest. Why I'm saying a simplest means, because the very first category I'm going to specify as a nominal data, nominal scale. It is a nominal scale. Because why I use the word simplest here? Because here the number attached with this data does not have any meaning. So the another name of nominal scale is what? It is a categorical data. Categorical. The classic examples is what? Suppose your data has a gender column. Gender column. You have a male. Male is attached with a number 0, and female is attached with a numerical label called 1. See, the idea of measurement, what is measurement? Any object you need to represent in terms of a number. That is our fundamental idea about the measurement. You measure the length and you specify the length in terms of inches or centimeters. So you represent the length or height or weight. These are all the different measurements. So here also gender also is a measurement you would like to represent in terms of some numerical value. Maybe I say attach 0 and 1 here. For the nominal scale data, the number does not have any meaning attached actually. So the higher the number, no, the female is superior than male, or if male is represented as 1, male is superior than female. Nothing like that. There is no, the number does not have any meaning at all. It's just a category. It's just a label. Maybe one more example I would say, like a Jesse, the player's Jesse number. Maybe you just take a cricket player's uh, T-shirt numbers. So for example, player 5, he's having a T-shirt number like 10. Another player is having a player 10. He's having a different T-shirt like 25. Okay, these number does not make any sense. The higher the number means the best player. The smaller the number is a weaker player. Nothing like that. Here, actually, the number does not have any meaning attached. It's a category. So that kind of scale is called a nominal scale. Number two, the second type of scale is ordinal. So this kind of this scale is slightly here. The number, I would say, the number has meaning. Example is ordinal means it's a rank. It's talking about the rank order in your classroom. So you have no ranking system. The first rank, second rank, third rank, and so on. Or in any competition, sports, athletes. Let us say I'm conducting 100-meter dash, and you are picking the top three. Okay, first in the race, first, second, third. Mostly this ordinal or even ratings also. Suppose you give a movie ratings. So 0 is very poor, and 1 poor, and 2 you can say it's below average. 3 is average, 4 is good, and 5 is excellent. These are ratings, ranking, these are all comes under this ordinal. But here you can notice number has meaning. Definitely a person have a number 1 is attached to a particular object, it has a meaning. It's a first rank holder. The number is attached 3, definitely is the number has certain value. But when we look at the third one, interval scale, let me take an example. Temperature or time. I'm going to compare this interval scale with ordinal scale. I'm going to ask you a question. Suppose I'm taking a temperature in degrees Celsius. Suppose I take 45 degree and 46 degree. Any two consecutive temperature, if you take, and you take a difference between 46 degree and 45 degree, we have a difference of 1 degree Celsius, right? And you take a difference between 34 minus 33, we have a difference of 1 degree Celsius. In what is the interval scale data? Any two consecutive record, if you take the interval is fixed actually. In time, if you take a difference of 10 hour and 9 hour, the difference is 1 hour. Even 3 hour and 2 hour, the difference is 1 hour. In terms of minutes, 5 minutes and 4 minutes, we have a difference of 1 minute. 8 second and 7 second, you have a difference of 1 second. So everywhere you have an interval is 1. But of course, naturally, number has a lot of meaning. Only except nominal scale, all other measurements, number has a meaning, but it has certain additional quality. What is the additional quality interval scale is having? That interval is constant. You might ask me a question, why not here also 2 minus 1 also 1, 3 minus 2 also 1, here also the interval is constant. But look very carefully in the ordinal scale. You might have realized sometimes you will be talking to your friends and family saying, just with 1 mark I lost the first rank, right? So maybe the difference between the second rank and first rank may be just 1 mark, but the difference between the third rank holder and the second rank holder, the difference could be 20 marks. Similarly, in a sports, no, if the person who reached the goalpost first may be crossing at 10 second, and the second person is reaching in 11 second, and third person could reach in 15 second. That means what we mean to say in ordinal scale, the difference, okay, the quality difference between 2 and 1 or the quality difference between 3 and 2 is not same. Whereas in interval scale, it's always same. So this is the additional characteristic that interval scale data is having. And finally, number 4, ratio scale. Ratio scale also having all the quality of the remaining 2. Number has a, of course it may not be in the order, but number has lots of meaning. And the interval is fixed here, like interval scale data, ratio scale data also. For example, let me take a kilogram, weight in the kilogram, or height in centimeters. These values, if I take two particular 57 kg minus 56 kg, any two consecutive record, if I take, the difference is same, like interval scale data. But additionally, ratio scale data has an additional quality, like ratio has a meaning here. Here additionally we have a Ratio is meaning, whereas the ratio is meaningless in the interval scale data. What is mean by that? If you ask me, for example, I could easily say in the ratio scale data, a 40 kg person, okay, a 40 kg person is equal to 2 times of 20 kg person. Right? A 40 kg person is twice heavier as a 20 kg person. Or a person which is of a height of 160 centimeter, I would say 160 centimeter, he is twice the height of 80 centimeter person. So always here the fraction, I can say the fraction as like a 2:1 fraction. Ratios having a meaning, but in the interval scale, ratio does not have a meaning. We cannot say, for example, 20 degrees Celsius. Of course, we are in the peak summer. 20 degrees Celsius in Tamil Nadu is not possible, like except the hill stations, right? Assume you cannot say 20 degrees Celsius, 2 times of a 20 degrees Celsius is equal to a 40 degrees Celsius. Okay, today we are experiencing around 40 degrees Celsius, right? In the summer, how you cannot say 40 degrees Celsius is equal to 2 times of 20 degrees Celsius. 20 degrees Celsius is very cool. 2 times of 20 degrees Celsius is not equal to. So ratio does not have a meaning in the interval scale. Of course, the one more characteristics ratio scale having in which the interval scale does not have is, in interval scale data, there is no absolute zero. It means what? When I say 0 degrees Celsius or 0 time, it doesn't mean that time does not exist or temperature does not exist. Whereas in the ratio scale, 0 has an absolute meaning. For example, when I say 0 kg, there is no weight. 0 centimeter, you can say there is no height. 0 rupees, there's no money. 0 years, age is 0. It has a meaning. 0 has absolute 0, it has a meaning. But in the temperature scale, interval scale, particularly if I say a temperature, say 0 degrees Celsius, it means it's not absence of temperature, right? 0 degrees Celsius, still it has a 32 degree Fahrenheit, or you can say in terms of Kelvin, 273 Kelvin, right? 273 Kelvin. Still 0 degree has a certain temperature, it's a freezing temperature, right? So this is what the predominantly your real-time data has, these qualities. According to this quality, we need to understand the characteristic of the data. Whether my if my data set has a column which is a gender, I need to understand this in terms of nominal scale. What are the different graphical measurements, or what are the measurements are possible for a nominal scale data? How do I treat the nominal scale data? Similarly, ordinal scale data, how do I treat? Interval scale data, how to treat the interval scale? Ratio scale data, how to treat? Predominantly, we refer this first two as a qualitative data, and the third and fourth category we call it as a quantitative data. In a broader sense, we can say it is a qualitative 1 and 2, and 3 and 4 is a qualitative data. Okay, next 15-20 minutes, I would like to address the usage of Python. Because when we talk about data science, the three software will come into picture. The three most popular software across the globe, particularly in the field of data science, ML and AI, is Python, R, and SAS. These are the three. Particular to the context of if you are a data scientist, you are going to develop the algorithm. These are the popular three software two packages: R, Python, and SAS. Except SAS, R and Python are open source. SAS is a software, it's a proprietary, it's a license. You need to get a license. Predominantly, clinical research company, clinical research and pharma, drug development company, drug research companies and all, they use SAS. Predominantly, I'm saying. R and Python are open source package. Now I'm going to show you the usage of R to handle, how do we use our software, Python software in this. There are two ways to use the software in your algorithm development, your analytics practice. One way is you have to install the software if you are using a standalone machine. Okay, if you are using a standalone machine, you can install the software in your laptop or in your desktop. And every software is associated with the integrated development environment. We call it as a IDE shortly, integrated development environment. The popular IDE for Python is Jupyter and Spider. So I'm going to demonstrate Jupyter platform, Jupyter integrated development environment. So if you wanted to use this IDE in your standalone machine, you have to download Anaconda package along with Python. So you need to download Python as well as you need to download Anaconda package. So again, there are two versions, two major. One is 2 series Python and 3 series. Predominantly, people have moved across the industry. People already moved to 3 version. Now 3 becoming more stable. Earlier 2 was very popular. Almost for a decade, it was very popular, and most of the deep learning algorithm and all. Now people started using the 3 versions. So when you start as a fresh, always recommend you to start with the 3 version. And so Python and Anaconda you have installed. This is Anaconda is mainly for the integrated platforms. One is a standalone machine. You need to install both and in your local machine. The second way is we can use a virtual cloud editor. So I'm going to use, there are different major players are offering. For example, I'm going to use Google Cloud Server, Google Colab. Colaboratory is it's a virtual platform in which you can write your editor program here. So virtual editor is going to act like your IDE here platform. Also, you can have your data in your Google Drive. Keeping your data in your Google Drive. So both your data and your editor are virtual. Whereas here, the first option, you have to download your Python and the integrated development environment. Also, you should keep your data in your local machine. Imagine you are working with a larger pool of data set. Over a period of time, you will realize working in a standalone machine or desktop or a Python, it won't make sense. So naturally, you have to, at one point of time, we have to move towards a cloud-based platform. I'm just opening my Google Colab. So once you, how do you access this Google Colab is like you have to access through your Google Drive. So you have to keep your data and Python files in your Google Drive. You have to upload those files. Once you have uploaded, now you can access the files like this. Since many of you are might be new to Python programming, so the scope of this webinar is not to teach you the start from the scratch of Python. After all, this is about a 90 minutes webinar. Just I'm going to give you the glimpse of how the data science, how you're going to implement a data science project or it's a machine learning algorithm. How do you build a machine learning model in Python programming? So we have lots of, so one of the powerful plus point of Python programming, why Python nowadays is very popular for this ML and DL applications, is Python has a very rich set of libraries to handle with. And moreover, Python is a general purpose software. Many of you are not aware, see, Python was there for 30 years. But now for the last 5-10 years only, particularly the academic industry is talking about Python, showing interest in Python in the last recent 5 years only. But it was there, 1989, it was developed to replace the ABC software. So Python is a general purpose software. You can build even you can build a game development applications or your database management applications or web development applications. People are using Python from several years before. But once the Python started, the usage of Python increases for machine learning and deep learning, data science particularly, it gains lots of popularity. So I'm going to use the virtual editor as well as the Google Drive. So I have to import my Google Drive. I have to connect my Google Drive to the virtual editor. So I need to mount my Google Drive. Content/drive is the root of everybody having a Google Drive login account. So your root folder will be always like a content/drive my drive. So inside that I kept my folder name is Python for ML Mahesh Anand webinar. So I'm going to just show you a glimpse of how a real life data looks like. So this is an automotive data set, car sales. It is one of the popular data sets in a data science field. It's popularly called as cars 93 data set. Actually, this data set is um, it is about the different car and its price with their different technical specifications. This is the data set of US cars data set taken in the year 1993. Most of the cars model, if you can see, it's a very old model. But however, let us not bother about the which year this data set is. Here the scope is how you visualize your data in your Python and what are the things you can play around with the data as the initial, the first hand information you get from the data. See, I'm loading this data. You can see the file extension is like CSV file. Python has a capability to handle varieties of data, right from CSV, Excel file. You can also directly read a type table from your any web page, HTML page. SQL data you can pull in. So according to the nature of the data, we have to use a particular library to read the data. And the moment I read the data, you can see the data size. It is a tabular data. I have 93 rows and 27 columns. Obviously, this is a smaller data set, but when you start working with some real projects, you'll be working with thousands of records. Always, it's not a good practice to display entire records. So we have an option to see the head and tail of the data. See, the moment I display the head of the data, we call it as a data frame. Data frame is a particular type of data, is a popular type of data type when we do the model building, machine learning model building and data science. See, as I'm talking about the different measurement scales, you can see by looking at the first 5 records the head will show you. You can see the manufacturer. As I told you, it is a nominal data, right? It's a categorical model again. So what model it belongs to, nominal, what type it belongs to, whether it's a small hatchback or mid-size or it is a sedan or SUV type. These are all the nominal records, and you can see the quantitative record like price. So this data set is popularly used for to predict the price of a particular car. Now let us quickly understand what is the business requirement. Why do we need to work with this data? What is the use of it? If you ask me, see nowadays every automakers are very we are they are very competitive, and any brand is very popular in the market. So the next brand they started giving a release the competitor of that brand. So in media and all, you can see like now Brezza rival. Honda is launching a Brezza rival, or Maruti is launching a Venue rival. Why they use the word rival? Because they're going to compete with that model, right? In that segment. So strategically pricing the car price is one of the business requirement in which every auto manufacturing industry is looking for. So this is one that particular domain, car data set. You can see the different specifications they have given, like what is the mileage in the city, because it is a US car data set. Mostly the units are the mileage in gallons, and yeah, we can see other specifications like airbags. Like there are this record, there is no airbag, driver and passenger, driver only, and drivetrain, whether it's a front wheel drive or rear wheel drive or it's a four wheel drive. Again, it is a nominal data. Cylinders, how many cylinders that car is having. So so we need to explore this data, and what are the factors affecting the price of the car? Which factor is playing a crucial role in determining the price of the car? Okay, now let me check some analysis between these variables. If you wanted to do some analysis, um, okay, let me visualize the price of the car versus. Um, let me take one maybe a weight, or I could say we have a horsepower. Can you notice we have a horsepower? Horsepower. I'm interested to see how price of the car varies with respect to horsepower and how price changes with respect to mileage. Okay, let us have a quick visually. Let us go through the relationship. So for all the plots, Python is having a very popular package called matplotlib package. So matplotlib. So I'm making use of that PLT function, plt.plot, or we have two functions. One is scatter. I'm going to see a scatter plot between what is my first variable, x-axis, because see, x-axis is, remember, always you have to put your independent variable in the x-axis. Y-axis, I need to put the dependent variable, because here I wanted to use price as a dependent variable. How horsepower is influencing the price. So horsepower I'm going to treat as my independent variable, and dependent variable is what the price. Now I want to see the XY scatter plot. My data, entire data is loaded in the capital B data frame. So I have to specify B of, you have to, this is the way you have to fetch a particular column. So x-axis is what the horsepower I'm going to use. Horsepower versus B of price. This is one quick analysis of whichever the variable that you are going to predict, because the y-axis is what you can easily decorate your graph like this. We have X label. What do you have in the x-axis? X-axis is the horsepower, and y-axis, y label you can set. Y-axis is the price. Just wanted to see already we have a set of 93 records for different types of cars with different pricing. You are analyzing the relationship of a price with respect to one technical parameter called horsepower. You can see as horsepower increases, the price also increases. It is a positive relationship, right? Obviously, we can easily understand it is a, because why I have taken this data set is everybody can understand irrespective of your discipline. That is why I have taken, because everybody, we know, we at least we can ride a two-wheeler, we know little tech specification about the engine, right? Higher the horsepower, naturally if you purchase a 200cc bike and 100cc bike, you compare the prices. Naturally your 200cc bike will be priced higher when compared to 100cc bike. So as horsepower increases, the price of the car also increases. What kind of relationship you can explore? Similarly, I'm going to analyze price with respect to another variable. This time I'm going to take mileage, because the Indian customers are very much particular about the mileage, right? The first thing they will ask how much mileage this car will give. So we have a mileage input here in our data, MPG city. Okay, let me take a city mileage and highway mileage is there. Let me take a MPG city here. So MPG in capital dot. So whatever the way your headers are there, in the same manner we should give. So mileage versus price. I would like to analyze mileage versus price. How mileage is influencing the price of the car. Look at this. This is positive relationship. As X increases, Y axis increases. Interestingly, you can see as mileage increases, your price drop, right? Actually, look at this is a negative relationship. Technically, once you are familiarized with the terminologies and all, I'll be using a technical term called correlation, negative correlation, positive correlation, and stuff like that. Since many of you are attending this, doesn't have any prior knowledge about, because the first time you are entering into data science terminologies and concept. So that's why I'm not, as much as possible, I'm not bombarding with lots of jargons and terminologies. With simple common sense language, I just use it. So as you see, x-axis increases, y-axis also increases. But here, as x-axis increases, y-axis decreases. It means what? The higher mileage cars are low priced. Naturally, you know the relationship between the power and mileage, right? Naturally, those cars giving a high mileage will have a less power, naturally. The cars giving a very high mileage will have a less power. Similarly, the cars will give a less mileage, or in other way around, I can say the higher horsepower, whichever the vehicles are giving a horsepower is very high, naturally your mileage will drop. Because for power, you have to trade off with the fuel. For more power, the engine will burn more fuel. Naturally, the mileage will drop. So the vehicles like SUV type of vehicle, 4x4 vehicles and or four-wheel drive vehicle and all, it will draw more power. If you are looking for power, you have to compromise with the mileage. So this is how the design engineers, they will be working on several parameters. Tomorrow, imagine a vice president of a team, for example, the sales team, they wanted to figure out, they are working with a new product. A new product is having so and so technical specifications. Okay. Now they wanted to strategically price their product along with their competitors. Okay. So if they have a prior last 5-10 years records of different kind of cars, let us to the context of Indian context, let us collect all the records last 5-10 years of different cars, right, across the different manufacturers, including Hyundai, Maruti, Nissan, and you take all the brands and you have this data set. Imagine tomorrow any car maker, they are going to launch a new car uh, in competition with another car maker. They could use such a model. We have not done any model building and all. I just given a glimpse of some how do you are exploring your data, establishing a relationship between the data set. So just one simple scatter plot I have given, and there are various ways to visualize your data exploration. For example, price alone, if you wanted to see how my price distributed. So already I have plotted that graph, what is the distribution of price. I'll show you. So price is a continuous quantitative variable. I have given, we call it as a histogram. So B of price, when you see a histogram, you can see the histogram. So this kind of histogram in the data science field, in statistics field, we call it as a right skew data. Because you can see in the right hand side, majority of the cars are in the price bracket of around 20 lakhs. Actually, here the unit is not in the lakhs, of course, in thousands of dollars actually. So majority of the cars are in $20,000 average price, but there are very few cars at $50,000, $60,000. They are expensive cars also inside the list. For example, Mercedes, Infinity, these brands are very expensive, so they are included in the data set. That is why it shows very less in number, 1 or 2 records. But majority of the cars are in the lower, the average price range of $20,000. So these kind of analysis, the moment you take the data set and you can have a view. For a quantitative data, what kind of analysis I should do. For a qualitative data, what kind of graph I should do. For example, quantitative data, we have discussed, right? Categorical data. We can see bar plot like this. We are talking about the airbags. Out of in my records, how many cars are having no airbag at all? No airbag. We have around 33 records. And the driver only, how many records? Driver and passengers. First, we have to start with a simple analysis of visualizing all the columns, understanding some idea and a conclusion about your variables. That will take you to have a realization of, okay, if I wanted to predict the price, what are the other independent variables influencing my price from your visual understanding, that is from the visual exploratory analysis, then it will help you to choose the suitable variable to predict the price. So this is just a preliminary analysis to start with the data. Then we have to do a lot of advanced analysis with the statistical measures and all. For that, you need to understand certain statistical terminologies. Because right from the school days, the moment I tell statistics, immediately mean, median, mode, or standard deviation. These are the certain terminologies already you're familiar with. But along with that, we need to study certain statistical ideas behind choosing the features. So we used to say that what is the descriptive statistics, what is the inferential statistics, how inferential statistics is playing a role in machine learning algorithm, and what is the difference between a statistical learning and machine learning. All those things are the building blocks of your ML algorithm building strategies. So of course, this 90 minutes webinar is just going to give you a hint of how data science, what will be the future and what is the scope of data science field, the near future of pertaining to your job placement strategies. When you make it, traditionally, if you look at your seniors, most of your seniors are placed in a different domain. But in the last 2-3 years, if you see, there are many of your seniors are getting into analytics domain. So if you wanted to develop your analytics skill set, definitely you should have a sound understanding of one Python programming, uh, at least Python programming. If it is if you know both Python programming and R programming, it's well and enough. And you should have a sound understanding of mathematics and statistics pertaining to the model building. These two are the ingredients, okay, to equip yourself as a data scientist. So what kind of roles are there for if you are a fresher or if you're 1 or 2 year experienced person? What kind of roles you will be called as a junior data scientist or machine learning engineer? This kind of job profile will be very much suitable for you if you are too much of interested in the data scientist role. Otherwise, on the other hand, if you are interested in Hadoop, I wanted to learn the big data structure like Hadoop, Spark structures, and if you are fascinated too much of fascination with database management stuff, warehousing, data warehousing, if you are too much interested in that, I could recommend you data architect role for you. Otherwise, if you are too much fascinated with data science, fascination working with the numbers, playing with data, really this field will be really suitable and for you. And the moment you start working with your own domain data set, it will be more fascinating and more interesting to you. The civil engineers, you start working with your own domain data set, it will be more of a fun. Structural data, you can work with structural analysis. Mechanical engineering, again, this is related to automotive manufacturing data set. You start working with image processing related data set for computer vision, pattern recognition applications. So once you start working with your own domain, still this field will be more of fun and fascination. If you have a real love towards math and stat, this is the field for you, right platform for you. So that's all about my talk. My focus is to give you an idea and insight about how Python is emerging as a very popular tool in data science field. Of course, now there are, see, the technology is very fast changing, right? So there are also other platforms are emerging competing with Python. One such software is what Julia. Julia is emerging rapidly as a uh, as an to improvise the Python development platform. Of course, it will take its own time because Python has a history of 30 years history. Whatever any new tools to replace Python or not, it will take its own time. But at least for next 5 years, you can say that there are a lot of industries are looking young talents like you to start work with their business data for model building, for building intelligence AI related models, for analytics or prediction models. And once you get a good idea on this data science, the basic data science prediction models, then you can take the next step ahead to specialize particularly on natural language processing. You specialize on time series modeling. You make a specialization on recommendation engines. So for all those specialization, I strongly believe this is a base and foundation. Once you keep this foundation very strong, on top of that, any kind of specialization um, we can easily go for. I hope you got some useful information related to data science, how Python you can make use of to make your career decision making. Now I'll be happy to answer your questions if you have any doubt related to anything related to this webinar. I'll be happy, and also the coordinators also will be joining with me to answer your queries and all. So once again, I just conclude this webinar by thanking the organizers, Francis Xavier College of Engineering department, and meeting all of you through this webinar talk. I'm very glad. So now it is open to questions. Thank you. Thanks for your patient listening. Yes, please.